Hello and welcome back to part 10 of the Qedit tutorial. We're going to talk about a few other opcodes that may get a lot of use when you try to flesh out your quest. A lot of these may have some extra functionality that you can determine for use later. One of the first ones we're going to start with is we're going to make a opcode called getPlayerHP. This opcode has various uses. The first use of this opcode is that you can use it to determine if someone is dead. It also keeps track of your TP values and your maximum values for both of these, so you could have some specific parameters for that. But usually when you use this opcode, you're using it for your current HP. In this case, the first register that we have for this is 40. That'll start the continuous registers going from current HP, max HP, current TP, max TP. For our purposes, we're going to use this to determine if a player dies. The function we'll use to determine that is a jump I does not equal to 0. And then we'll have this function loop on itself. For this function specifically, I'm also going to make a sync counter that is for delay running the action. First one we'll do is just going to be a large series of syncs. For this one, we're going to have 10 syncs in a row. The second one of this is we're going to have this function call function 50 3 times. This means that if you use function 51, you are going to call 30 syncs. If you use function 50, you'll only call 10. As you can see, this also helps save a lot of space instead of making a function that just does a large amount of syncs all at once. You can kind of compartmentalize it down a lot better. We're going to throw function 50 into function 40 so that this performs this check 3 times a second. In the event that your HP does equal 0, since I'm using a jump I does not equal, it means everything after this is going to run. So what we'll do here is we'll use another opcode that I'm going to explain called scroll text. Scroll text is a higher end chat. It's mostly used for information that can be relayed passively. It has a lot of inputs, and all of these can be broken down reasonably well. The first two is a coordinate that where the scroll text box is going to start from. The text box spans from left to right and top to down. PSO has a landscape of about 640 pixels wide by 480 pixels tall. So if you wanted to have this spawn in the top left corner of the screen, you would have these first two as 0, 0. For this one, we're going to have this be somewhat in the middle of the screen. This is going to be the same values that are used in like maximum attack when it tells you how many enemies are defeated. The next two is how wide the box is and how long and how many columns are in the box. So if we wanted to say we wanted to have 5 columns so it can show a couple lines and have this be about 32 units long. 32 units is not character for character since some are longer and shorter than others. But in terms of the units that the scroll text allows, this can give you about the equivalent of 4 to 5 words in there. The last D word is the window style that this is. Normally this is going to be 2 for scroll text because this means there's no box, no color background behind it. Most scroll texts have 2 for this last D word. This float value is how fast this text actually moves. And this can be anywhere from 0, 3. The higher the number, the faster the text goes. So we're going to have this be at a reasonable speed of about 1.5. The register is the one that sets the register to 1 after this function is completed. What we'll do for this one is we'll just set this to some random register. We'll do 39 since it's not being used. And then finally, you have the string, which is the text that shows up when this opcode runs. We're just going to have a basic message of, you have no hit points. This function's just like other messages. You know, you can use word wraps, you can use new lines, all of that. Generally, a scroll text will be accompanied by a secondary function that has 3 syncs. And then a register check for the register that it sets to 0. Which just means that it wants to wait until this scroll text is completely off screen until it's done with its message. And then from here, we'll just do a simple jump back to function 40, so this cycle begins anew. So you may be wondering, what if the player has escaped all when their HP hits 0, and they have this function happen? What we could do here is we could use an opcode called pdeadv3, which checks to determine if the player has escaped all or not. This function is a little backwards with its register inputs because the second register is the one that would take register 250, with the first one being whether or not they had escaped all or not. In this example, we're going to have register 38 determine if they carry the value for that. If they do carry escaped all, then this register will equal 0. So to loop this back with the rest of the function, we're just going to make a jump by where if register 38 equals 0, we're just going to have it run back through function 40. This way it has a double check to determine if you really are dead, where if you have no HP and then have no escape dolls, if these are both true, then it will run the scroll text, which runs function 41 and then sends you to Pioneer 2. And then finally, to make sure that this is all called, we're going to put a thread stage in the temple floor handler. So if the player ever dies in temple, then they will have a message show up that tells them they're dead. From here, Kayak is going to talk about keyword and a couple other opcodes that can go along with something like this.
Okay, so first we will talk about the go floor function or opcode. Basically, this opcode is very simple. It uses 2 registers. We can put it right here. So what you want to do is you want to have a LEDI for a random register. Let's use register 100. And we can have it as 0 because I want to return the player to Pioneer 2. And then we just do go floor. And you want the first register to be register 250 for get slot number. And then the second one is the register for the floor number you want to go to. So if you wanted to send the player to another floor, you just change this 0 to whatever floor you wanted to send them. Alright, so I'm actually going to move this down a little bit because the way I would have that set up is the scroll text wouldn't even occur because the script reads from top to bottom. So as soon as the scroll text gets read, you just instantly get warped and you'll never ever see the scroll text. So we're going to move this down here so that there's a bit of a sync window before this warp happens, and we're going to just change this to a ret. Next I'll talk about keyword detect. So keyword detect, you actually will have to put in function 0. So let's just put it right here. You're also going to need to put it in the floor that you want the keywords to be detected in. So in this case, I want to put it in temple. So let's put it right here. And then we create a function. Let's use function 52. Now this one, it's not going to come up when you type up, so if you just type keyword, it'll just show up right here. So keyword has to be tied to a register. So in this case, let's see. Let's use function or key register 101. D word. This is register 250. So it'll detect it when the player says it. And then the string, this is the string that you want to have perform an action. So I want to make this freeze. And it is not case sensitive, so you can type a lowercase f and it'll still pop up. After this, we want a switch call. The way this works is basically register 101, 0 will be inactive, as if freeze was never typed. So we wanted this to just go to 1. And then the second position, which is if it is active, we go to a new function. So from here, basically the goal of what this is going to do is this is going to be a keyword that the player can type, and we will notify them somehow through in the quest that if they type the word freeze, the monsters are going to freeze for approximately 3 seconds. So I want a call 51. Oh, I put it in the wrong place. We want a ret here. Actually, we want to start function 52 with a sync because this function is eventually going to get threaded. Okay. So what I want to do here is I want to have the function wait a bit when it gets called. The problem is the keyword will continuously go off if freeze is on the screen at all. So let's say I didn't have any syncs in this function. If you were to type freeze, it would go off approximately 4 or 5 times. So I want it to wait 1 second before the freeze goes off. And we want the opcode freeze enemies. And I want to make about a 3-second timer. So we will call 51 3 times. It's approximately 3 seconds. Then you want to clear register 101. So register 101 is tied to the keyword itself. So I want the player to be able to type this multiple times. So they can activate it more than once throughout the quest. And from there, we put a ret here. We're also going to need to thread stage function 52 for our floor handler and temple. Okay. We're also going to want to unfreeze the enemies as well. Because if you freeze the enemies, they'll just never move ever again. So, function 52 will get called if the player types freeze. It jumps to function 1. If they don't type freeze, if they do type freeze, it jumps right to function 53. Sorry, calls, not jumps. It waits a second. It freezes the enemies for 3 seconds approximately. Clears the register so the player can type it again, and then the enemies unfreeze. And it returns. And that's basically how you would use a keyword detect. There are a lot more fancier ways you can use this as well. If you take a look at Festivity of the Beach, that has about 30 or 40 keywords in it, and they do some very interesting stuff with that. Sega kind of went crazy.
From here, there is a lot more opcodes that you can use. These tutorials are meant to get you started, and then you could use the wiki to experiment with some other opcodes that you may find interesting or want to experiment with. But from here, we plan on fully completing this tutorial quest and then showcasing the completed product. While the completed product will not include all assets that we have laid out for you already, there will be some crossovers. Some things will stay in place, it just may be moved around. So all of these elements that you have become familiar with in this series may be expanded upon, some may be moved.
So the final product of this is going to be basically a playable quest that will teach the player the basics of the game. While in this series we wanted to teach whoever was watching this the basics of how Qedit works, the final product of this will be teaching new players the basics of this game, basically. We will plan to make this a downloadable quest as well. There's also going to be some server-side functions that we are going to include in this as well, but we won't really show that off in the video as it's not relevant to everyone that watches this. Thank you for watching the main part of this series. We hope to add some later episodes somewhere down the line where we go more in depth into very specific opcodes that might be difficult to use or just unclear in nature how they work. So we will do our best to go over some and explain those. Until then, thanks for watching.
Thanks for watching.